welcome everyone to one of the Earth Mover demos. Hopefully some of you got to see Brian's demo last week, looking at ECMWF weather forecast ingest. But today I'm going to be talking about something different. I'm going to be talking about how you can use Earth Mover as a multimodal scientific database. And so we're going to talk about a bunch of different types of data and get into that. But grab my screen here. So before we get to the hands-on demo, I'm just going to tell you all a little bit about Earth Mover and our product and what I mean by multimodal database and all of that. And then the second half of this session will be hands-on Jupyter Notebook style walkthrough of our product, and we're going to look at a bunch of different types of data. And then there will be some time for questions at the end, so stick around. Cool. So Earth Mover, we are a public benefit corporation. We have a stated mission to empower people to use scientific data to solve humanity's greatest challenges. And you know what that means includes climate change, and it includes electrification, includes energy and biology and a bunch of other hard scientific problems. And we feel that those fields are underserved by existing data infrastructure. So together with my co-founder Ryan, we started Earth Mover about 2.5 years ago. We both are personally trained as scientists. So I'm a civil engineer and climate scientist. Ryan's an oceanographer. We met working on open source software together in service of our own scientific research. And really we're feeling the pain of not having great tools for working with this data. So we ended up spending our time working on tools, and over my own personal path is that slowly ate my academic ambitions and became an ambition to help people work with scientific data more effectively. So along the way, we've started the Pangeo project. We've worked on X-ray and Zarr for many years at this point. And so those are our open source roots, and we're going to be using many of those tools today. So at Earth Mover, we work with organizations that in many cases consider themselves as organizations that are building scientific data products. And by data product, we mean a specialized curated data set which drives business value in one way or another for the organization. And so give 3 examples of the sort of customers that we work with and what their data product might be. So the first is Silvera. So this is a global forest carbon inventory data product that they work on. And for that means bringing in lots of different geospatial data sets, climate data sets, and tracking the amount of carbon using machine learning and various data analysis techniques. Kettle is does probabilistic wildfire risk estimates. And so here again, they're looking at short to long-term risk of wildfire, needing to use lots of different multidimensional array data sets from things like CMIP or reanalysis to estimate the future fire risk. And then finally, RWE, the AI weather group there, building AI weather models for use in weather or for energy applications and trading. So in all of these cases, they're building their own data products. What we see when we're talking to these customers, and I assume many of you on the call would, this would resonate, is that you run into a similar set of challenges when you're building data products. The first one we see most often is what we call the data swamp. Just a million choices and options and of different formats, where the data is coming from, and what technologies you can use to access that data. And this really limits the ability for us to collaborate, reuse, and move quickly with the data that is important to us. We also see folks struggle with poor performance. And often cases, we're talking about terabyte to petabyte size data sets. And slow I/O performance is a serious bottleneck, not just for the computational load, but for the ability of the team to iterate and try new things and to move forward. And then finally, what all of this adds up to is chaotic data delivery. How are you going to get that? Even once you've maybe assembled your or organized your data swamp, how are you going to get this data out to your stakeholders, whether that's an end user or a customer of yours or an internal stakeholder? There's just a million options around how you're going to do data delivery all the way through the life cycle of your data. And so these are pains that slow us all down, and these are the sort of things that we're interested in solving at EarthMover. So what I'm going to show you today is a demo using the EarthMover platform, and I'm going to specifically focus on Array Lake today. Go see Ryan's demo. It was recorded, but it was a week ago if you want to see the Flux aspects. But this is what the EarthMover platform looks like. So we are a data platform, a data lake platform built on top of object storage, so cloud object storage. We integrate with Google Cloud, AWS, Azure, or any other S3 compatible object store out there, and we sit on top of that cloud infrastructure and provide specialized tooling that's specific to scientific data. So we have a number of elements here that I want to walk through. The first is Icechunk. So this is an open source storage format. I'll give a whole slide on it in a bit, but this is really the foundation. This is the data model that we've used that interfaces with the object store directly. On top of that, we have Array Lake. So Array Lake provides a data catalog, data governance tools, and then various optimizations for working with this type of data in a managed environment. And then our most recent product launch was Flux. This is an API gateway, serverless API gateway for distributing and serving data that's in Array Lake. So we have a number of OGC APIs, EDR and WMS for serving data, as well as an OpenDAP endpoint available through Flux. Today, we're going to operate directly against Array Lake using Xarray and Zarr and Icechunk. And this is how we see many of our customers today working with this data. If you're used to Python, you like Xarray, this is a great way to work at scale and really efficiently. Flux is really the part of our product that's about delivering this data to other environments. So maybe this is ArcGIS, maybe it's users in R, maybe it's a front-end application in Mapbox, or it could be a spreadsheet application in Microsoft Excel or in Google Sheets. So I'm not going to spend a lot of time talking about Flux today, but I did want to make sure everyone saw that there's really two parts to the product right now. And today we're going to be spending most of our time looking at Icechunk, Array Lake, and Xarray and Zarr. So like I said, our the roots of this company are in open source. And so want to be kind of explicit about which parts of our product are what we think of as open source and which parts are part of our proprietary product. So this is how we've defined our open core model. So what do you get with our open source is, we remain active maintainers of Xarray and Zarr, as well as XPublish. So these are the kind of three open source projects that have existed since before the company, but we continue to maintain them heavily. And then finally, Icechunk, it's the storage format, provides transactional functionalities on top of Zarr, is a Apache licensed open source project that we are developing and maintaining, but is freely available for everybody to use. We really hope that you all get a chance to use it, and would love to hear about your applications of Icechunk, even if we don't end up working together. And then the EarthMover platform is, what do you get with that? Everything in the open source column here, plus, so you get Array Lake. This is this kind of turnkey data management layer for your scientific data, and you get Flux. And this is a managed deployment of APIs, logging, metrics, all the pieces you need to put a production API gateway together. Today we're going to talk about what we call the multimodal problem. And really, it's how do I store, catalog, and query X, where X could be a lot of different things. A lot of our demos use weather forecast data. Certainly going to show you some of that today, but nobody just has that type of data. And so oftentimes we see folks trying to make sense of how am I going to bring in all this different types of data, a lot of which just doesn't fit in other data systems, and then make good use of it. And so some of the types of data that we're interested in exploring, and we're going to explore together today, are observational and sensor data. So this could be time series measurements from weather stations or IoT sensors. Could be from a multi-sensor platform. Could be from LiDAR, radar, sonar. These are multi-dimensional arrays, but they're not your standard data formats, and they're often pretty tricky to work with. We might also be talking about remote sensing imagery. So data from Landsat is a good example, or hyperspectral satellite data, which we'll take a look at later. You might also have visual media. So you might have a stack of photographs. Maybe a weather station that you operate also has a real-time photo, like a once-a-minute photo stream that you're being given, or video. Today we're going to look at some drone video and look at how we can store and manage that. And then finally, the stuff that's probably like the bread and butter of what we do, and where Zarr and Icechunk and X-ray have been used widely in the past, are for things like simulation outputs. So weather models, climate models, that sort of thing. And then finally, also machine learning artifacts. So that you can put the model weights from PyTorch or TensorFlow into this data model. What we've learned is that all of these different data types that I've been talking about are in-dimensional arrays, right? Some of them are one-dimensional, some of them are five-dimensional, but nevertheless, they're all in-dimensional arrays. And so what we are showing today is the ability for you to use the Zarr data model together with Icechunk to store everything from time series data, RGB images, video, all the way through simulation data. So that's what the stack is going to look like for this multimodal database. We're going to use X-ray today as our query layer. We're going to use Zarr as the hierarchical data model and the data format for the in-dimensional arrays themselves. And then we're going to use Icechunk as the transactional storage backend. So this is going to give us the ability to do ACID transactions, version control, and that sort of thing. And we're still going to rely on cloud object storage under Icechunk. So today we'll be using AWS for all of our demo, but Google and Azure are also an option. Okay, a couple minutes on Zarr and Icechunk, and then we'll hop into the demo. So Zarr is an open source format for chunked compressed in-dimensional arrays. It has a similar hierarchical data model to HDF, allowing for groups and arrays and user-defined metadata. The arrays themselves are chunked, and you can chunk those data sets or break them into blocks, as this figure is showing on the right, along any dimension. So very flexible partitioning is available. And then finally, Zarr is really built from the beginning to be optimized for concurrent reading and writing from multiple threads or processes. So unlike a standard file, you can read and write to it from many processes at the same time. Finally, it's multi-language. There's implementations in a bunch of languages at this point. This is an incomplete list, but Python, certainly, Rust, C, C++, Fortran, R, Julia, etc. So as I mentioned, Icechunk is a project that we've been working on in Earthmover over the last year or so, and it is a transactional cloud-native storage engine for Zarr. So it exists one layer lower in the stack than Zarr, and it offers features like ACID transactions, data version control, virtual data sets, the ability to ingest data without having to copy it from archival sources, and really is meant to provide a really stable, high performance foundation for using the Zarr and X-ray stack. So it's compatible with X-ray, virtualized Zarr. There's even now a Rust implementation called Zarrs that has bindings to this as well. So Icechunk itself is written in Rust, so we get some really good performance benefits from that. And there's a Python API, and it's, like I said, available as an Apache 2 open source project. Okay, so what we're gonna do now is we're gonna switch over to a demo. I have a Jupyter notebook that I'll be showing. And but before we go there, I'm gonna spend a couple minutes giving a quick tour of the Earthmover web application, what the platform looks like, showing you how the catalog, data management, and governance capabilities look in the platform today. And then we'll switch over into Python land, and we're going to access a bunch of different data sets of different modalities from Python. I'm going to really try to hammer home that how the data model is both incredibly flexible and how easy it is to work with this data using X-ray and Zarr together. So I'm going to switch my screen over, and then we'll get going on part 2. Okay, so now what I have up on the screen is the dashboard for the Earthmover demos organization inside of ArrayLake. So think of the model inside of ArrayLake is similar to GitHub. You have organizations, in this case, Earthmover demos. There are users, repositories. We have services. So in this case, we're running 3 Flux services. Won't spend more time there. But we also have entities like buckets that connect to different cloud storage backends. What you see up here on the dashboard right now is just a preview of kind of what this organization's Flux usage has been over the last week. But I'm going to hop us into the data catalog to start. So here I'm looking at a list of repositories that are available to me as a user in the Earthmover demos organization. And I'm going to scroll a little bit. You're going to see there's a bunch of different data sets here. And each of these data sets has some metadata attached to them. I can see their Icechunk repositories. They're in the Earthmover S3 bucket. Today, we're going to use, I clicked on one of these tags, and that is allowing me to filter this list. And so today, we're going to be looking at the data sets that are in that have this demo multimodal tag on them. And so you can see we're going to look at some time series data, some video data, some images from Hugging Face, some radar data, hyperspectral data, and then some Era 5 weather reanalysis. So this is a look at the catalog. I'm able to also do things like search across. So I just went ahead and I just typed in Era, and I immediately got filtered down to just this data set. I'm going to go ahead and look inside of one of these. We'll switch back to this periodically through the rest of the demo. But here we see I'm now looking inside of one of my repositories, and I can start to see the contents. So I can see I'm on the main branch, so similar version control model to Git and GitHub in that sense. And then we have 2 groups here. We have a spatial and a temporal group, and I'll just click into the spatial one, and you can see that there are 6 arrays in this group. There's some metadata associated with this. It says it was created by Earthmover a few weeks back. And I can move in and one level deeper and see that this 2-meter air temperature variable is 3 dimensions. I can see the shape. I can see the metadata about it, and I can really start to understand what data I have. I can also understand how this data set has changed. So this is just a demo data set. It hasn't changed all that much, but we can see that Ryan initialized the data set and then ingested some data and fixed some attributes later. So take a look then at the control settings for this repository. You can see I can manage the metadata. I can see what bucket this is in. I can make it public or private. I can also edit which members have access to this. In this case, the whole organization has access to it, but I can add specific users and make them readers or writers. All right, so let's then, to use this data set, we have to hop into Python, and so I'll do that here in a little bit, but we're gonna be using the Python API extensively today. The last thing I was gonna show is just that there's also at the organization level quite a broad array of tools for managing access control, governance, and connection with your buckets. And so you can see here, this is the list of users in our organization. You can see they all have different roles. We have API clients, so these are machine tokens. We won't be using those today, but this is a way to provide automated access to Array Lake. And then finally, the buckets. And so here you see a mix of S3 and Google buckets, and Array Lake really provides a higher level abstraction than the individual bucket for you. So you don't have to think about credentials for this or that. Array Lake is going to kind of handle all of that for you. So I'm going to jump back over into the catalog, and from here we're going to move into the notebook session of the demo. I'll take a quick drink of water. Okay. So yeah, okay, good. My notebook's up on the screen. And so the goal of this notebook is really to show us all how the stack I was talking about before, so Xarray, Zarr, Icechunk, and then Cloud Object Storage, can be used as a really performant and accessible multimodal scientific database. We've already ingested a number of different data sets into our Array Lake catalog as Zarr and Icechunk. And the ones we're going to focus on today include ERA5 reanalysis, hyperspectral imagery dataset from Wyvern, some NextRad radar observations, some in situ weather station observations, so time series, a big stack of normalized RGB imagery, and a short drone video. And the point of this demo, I just want to be clear, is none of these data sets are particularly large today. The goal is not to show you how each of these data sets can scale. That would be a great other demo. So you're going to see me take a couple shortcuts so that I can get through all of this in the next 5 or 10 minutes. But the idea is really to show how the data model works and the API works. So we're going to be using Xarray as our main query engine. We're going to use both the Xarray data set and the data tree, the hierarchical data model there. And the parts beyond Xarray, the parts of Array Lake that we're going to be using are really 4 main parts. So the first is the authentication layer. So we're going to log in, and Array Lake will be checking to make sure that I have access to the Earth Mover Demos organization. We'll use some basic discovery tools for finding data sets that are relevant to this demo. We'll use the catalog or the Python client to check out Icechunk data sets and start to use them. And included in that is the functionality that Array Lake provides for obtaining temporary credentials to the underlying object store. So all of this is going to be handled by Array Lake, and as we go through. So the first thing we're going to do is do some Python imports. So we're importing NumPy, Xarray, and Array Lake here. And then I logged in before this, so you didn't get to see the whole flow, but you did get to see that it's refreshed my OAuth tokens and logged me in. So we're all set, and at this point, the Array Lake client knows who I am, and when we are talking to the catalog, it's going to be as if it was me. So that's good. So The first thing we're going to do is do something similar that I did in the web app a few minutes ago, which is just filter the repositories down and figure out what repositories we're going to be working with. So here I'm going to list all the repos in the Earthmover demos organization that have this demo multimodal metadata tag on them. And you can see here we have the Aero5 surface, the HF images, hyperspectral, etc. And you can see the tags that are associated with them. From here, we're going to do some basic analysis on each of these data sets and highlight the different data structures that each of these data sets have. So when you're using the ArrayLake Python client, the get repo method is responsible for checking out a repository and giving you an Icechunk repo in return. And so that's what this line here does. So we're saying, I want to get the Aero5 surface data set from the Earthmover demos organization. So, run that. And what's happening in these next two cells is the, now we're going to learn a little bit of Icechunk, but so Aero5 repo.read-only session. So I'm checking out a read-only session of this data set, and I'm doing that on the main branch. And so I've done that, and then I'm just going to open that data set as an X-ray data set using the open Zarr function. And so this is what I get back. I have this hypercube, latitude, longitude, and time, and then it has 3 data variables and some user-defined metadata. And this is a pretty large data set. This is almost a terabyte per variable. And you can see it has, chunks that are about 100 megabytes in size. So the 3 variables here, by the way, are U and V. So these are wind variables at 10 meters, and then the 2-meter air temperature. So we can then take that 2-meter air temperature variable. We can select out a specific time. So I chose June 11th, today's date, back in 2021. And I'll go ahead and plot that. So we're going to plot a map of that. And you can see this is the global 2-meter air temperature at 12 Zulu on June 11th. So this is pretty basic stuff. If you've used X-ray before, you've maybe even made an Aero5 temperature map before, and wanted to start there, and then we'll get progressively more complex. All right, the next one that we're going to take a look at is a hyperspectral data set. So this is a remote sensing platform from another company called Wyvern. It's an open, one of their open public data sets. And what we have here is a single scene from this data set from the, I think they call it the Dragonet sensor, if I understand their terminology correctly. And we have one variable that has 31 bands in it. And so we're looking at that here. We see this whole array is 7 gigabytes. There's a bunch of chunks in it. And so we can analyze this data directly, just like we did the Aero5 data. But now, of course, we're not using data from a model, but instead from this hyperspectral sensor. So it's actually much higher spatial resolution, this data set. And so we're going to load just the 20th band here. And just to make the plotting a little faster, we're going to coarsen it by a factor of 8. Our eyes wouldn't be able to tell the difference because this data set's so high resolution. But here is a view. I'm going to change my screen size just a little bit just so we can fit this whole thing in here. Hopefully that works for the Google Meet. So here's a view of that hyperspectral data. It's beautiful. Okay, another type of data that is pretty unique and is not one we run into as often as I'd like is radar data. And so what I'm going to show here is how you can open up the data, the NECRAD KVNX data set with data tree. So data tree is X-ray's hierarchical data format. And before I make a plot of this, I'm going to switch back to the web app for a second and just give a tour of how this data set is organized. So what you can see is that this data set is really utilizing the hierarchical data model of Zarr much more than the prior two data sets needed to. And so in this case, we have a group, VCP12, and inside of that group are a bunch of other groups. And so sweep 1, 2, 3, all the way up to sweep 16 are different patterns of the radar as it's measuring at different elevation angles. And so inside of each of these sweeps is its own set of measurements. And so here you can see a bunch of these. We're going to use the dBZH variable in our analysis today, but you can see that it has, it itself is a three-dimensional array. So with that context in mind, I'm going to come back here. And so we've already opened this. And so you can see these are those 19 groups. And won't make us scroll through all 19 groups, but this is what X-Ray's data tree class is really good at, is representing this all for us. All right, so we're gonna make a plot of this, and just so we can see what this data looks like. And I'll walk very briefly through what this is. We're gonna look at the first time step. So that's what this ICEL VCP time 0 is, and we're going to look at sweep 0. So this is the first sweep as the radar is going through its elevation angles. We're going to, like I said, look at the dBZH variable, and we'll make the plot. So we'll let this load. And those of you that have seen radar data before will recognize some of the patterns here. It's obviously measured in a circle, so there's not data outside of that. And this is the sort of thing that if you're familiar with working with radar data, you would know how to then turn this into rainfall rate or some other parameter. Okay, so the next use case we're going to look at is weather station observations. So here we've ingested a set of, we're going to go back. Set of weather stations in as essentially tables inside of our Zarr data set. And here you can see, again, we're using the hierarchy more, a set of 10 weather stations. These are the weather stations around the Seattle area where I live. So we can then see that there's a bunch of different meteorological variables available. And happen to know this is all daily time step. So, and there's some extra metadata in all of this, which is cool. So with that said, let's go ahead and open it. And we are going to do just some very basic analysis. We're going to look at the long-term kind of behavior of temperature and precipitation in Seattle with a bit of smoothing. So we're smoothing by 21 days so that the figure is a little more legible. And you can see the annual cycle over the last few years at this particular station. You can see that it rains more in the winter when it's cold. And report that that's true. That's how it works around here. And then this was just yesterday. You can see that the average temperature is creeping back up. Summer's starting to get here, and precipitation is starting to fall off. So, totally work with time series data in this format just as well. All right, just a couple more here. We're going to now look at some basic imagery. So I pulled some images from a Hugging Face data set that had a bunch of labeled storm clouds and non-storm cloud images. And so what this data set is 302 RGB images with a label that either says 0 or 1, where 0 has no storm clouds in them, and 1 has storm clouds. And so I put them into Zarr, and now I've opened them with X-ray, and you can see just that we have this 4D data cube of images, and then this 1D vector alongside it of labels. And I can use those just as normal images. I can pull them into NumPy. In this case, what we're going to do is just take a random choice of 16 of those and plot them in a little 4x4 grid so that we can just see what those images look like. The label on the top here is whether or not this data set thinks they're a storm cloud or not a storm cloud. So, fun to see the pictures, but also interesting just how the data model is not all that different from how imagery would typically be stored. We can put them into a Zarr data set just fine. Okay, and then the last one I wanted to show is really an extension of RGB imagery, which is video. And so here I'm going to open up a data set. Let's actually switch back to the video demo. And we're going to look at this one. So here we're going to look at this data set called just this video data set. We got it from pexels.com. We can see that in the Zarr metadata, it has 4 dimensions: frame, Y, X, and C. So Y and X are the horizontal and vertical axes, and then C is channel, and then frame is the time axis. And then it's chunked in time, meaning we've partitioned this data set so that the data set is broken up in blocks of time. So we'll go ahead and open that. And immediately we get to see this X-ray data set. It has this video variable in it. And I can pull any single frame out of this and look at it as an image. And so I can explain now that this is drone footage flying over this road, and there happens to be a cyclist riding down on the road below. Of course, that maybe that's not all that exciting. We can also animate that video and bring it back to the video state. And so what I've done here is just a little bit of matplotlib and IPython display magic. And when it ran that, and now we have the same image that I was showing before, except I can press play, and we can see that the video plays from here. So hopefully this was a good tour of how different data types and formats can fit inside of the Zarr and Icechunk model. And I'm going to switch back to my slides to wrap things up, but I'm happy to take questions after that. So, okay, so just to review, the high-level goal here was to demonstrate how we can put different data types, whether it's video, time series, imagery, radar data, hyperspectral data, you name it, into the Zarr data model, and how you can use Zarr and Icechunk and the Earthmover platform to organize, govern, and then query that data. And so with that, I think we can pause here, and happy to take questions while there are some.
Yeah, so can you hear me?
Yeah, we can. Perfect. Thanks.
Yeah, so naturally I have a climate modeling background, but I'm now working in reinsurance. So Hanover Re is one of the 10 largest reinsurer in the world. And I'm working in the parametric department. So parametric insurance is a little bit different from traditional insurance because we rely on data. It's data driven. So we set our insurance structure based on data. So for example, if we say that, okay, it will rain in a specific region for more than like 300 millimeters per month, then we use that one as a proxy for a loss, assuming that if there's a flooding. So we don't do the claim assessment directly if the flooding happens, but if the rain data says that it's more than 300 millimeters per month, we pay the claim, irrespective of whether there's a loss or not. So it's purely data driven. So we need a lot of data to be able to price this kind of insurance program. And that's what I'm trying to do. And at the moment, we don't have a specific data infrastructure available. So I'm planning to do this by building something on S3. And yeah, I had Zarr and Icechunk is something that can really help us. But then I wanted to learn more about the whole array lake that Earthmover is developing to see if it can benefit us or not. So that's why I came.
Yeah, great, cool. Yeah, well, this is certainly a use case that is really interesting to us. And the question I would have for you is, what are the have you thought through what are the sort of data sets you're going to need for that? And as you're thinking about the cloud and all of that, which ones are going to be the highest priority for you?
So I think at the moment the one to rely on are mostly the reanalysis data.
Mm-hmm.
Also, for example, like a data set from NASA, like IMage, or chips data. So with our clients, especially from the agriculture side, they rely mostly on chips. So that's also is mostly just weather or reanalysis data.
Yeah. Yeah, makes sense. So yeah, I think I showed Air 5 here today, so I think there's some good analogs there, and we're happy to follow up with you.
Yeah.
Cool. All right. So yeah, there's a question in the chat from Sambit, who is asking whether or not the Zarr format can be used with archival data storage files like netcdf on traditional HPC systems. So there's really two parts to this answer. And the first is whether Zarr can be used with netcdf data directly. So, what I was showing you today is all this data had been ingested into Zarr and Icechunk directly, sometimes from a netcdf file, but the data was basically duplicated along the way. Icechunk also supports what we call virtualization, so the ability to ingest data directly from a netcdf file or similar, could be HDF, GeoTIFF, etc., without actually copying the data, so through a referencing process. And so the answer is yes, that works. We've been working on projects like Kerchunk and more recently on virtualized R that allow that to be a really seamless process. And so that's the first answer. I think the answer is yes, you can definitely do that. The second answer is about traditional HPC systems. And so we haven't spent much effort optimizing Icechunk today for use on HPC systems. It does have a local file backend, but it is highly unoptimized, I would say, meaning we haven't touched it with any specific force there. That said, Zarr and Icechunk we know of applications where people are using them on local file systems. They have some benefits and some drawbacks, specifically around just like the number of files. Zarr is really built as a cloud optimized format and works really well in object storage, where the number of objects doesn't really have performance implications. But all that to say, these can all work on a local file system as well. We have about 30 more seconds, and if there's not any more, we'll let everyone go.
One question just came in from Molly Blank, Joe.
Oh, okay, great. All right, newer to much of the data engineering, but interested in how this can help close gaps between remote sensing and ecological survey data. Working with embeddings from imagery, spatial species observations, NDVI, et cetera. Yeah, I'm curious if others are working with a collection of data sets that are looking similar. But Molly, this sounds quite interesting, and it sounds like there's you really kind of just laid out the multimodal use case here. I didn't include audio recordings in this, but they'd fit in that time series block of the demo pretty closely. And Molly, you should feel free to come off mute if you just want to chat too. So.
Thanks. Definitely shy. I mean, I think it's certainly not a question, but wanted to say hello. And I think this is really interesting. So maybe I will, while I'm here, ask the question, like where is the best place? Like, is this demo available for us to try and like recapitulate it and tweak it? I know we don't have access to sort of the data end of things. So where can we play?
Yeah, absolutely. So, a lot of what I showed today is open source stuff. The parts that were specific to our service were the catalog and the Python client. But also Icechunk and Zarr are open source, so is X-Ray. So we'll definitely be making the demo available, and happy also to talk about how we can help you get up with a demo of your own to start to play around with this.
Yeah, maybe that's the right answer. That'd be great. Thank you.
Yeah, Molly, we'll follow up with you after the call here.
Perfect. Thank you.
All right. I'm going to do a final call for questions. Yeah. Okay. So Alejandro asked a question about pricing. Yeah, our FAQ mentions a platform fee for ArrayLake. And then is that the only charge if you handle your own object storage and compute? So the answer is yes. There's a number of kind of potential extensions to that. And so, a platform fee is kind of how the basic access to the catalog and governance layer works. There's if we're handling the storage, it sounds like you would handle your own storage here, but if we're handling the storage, there's a consumption-based storage, just like there would be with S3 or something like that. And then Flux is also consumption-based. And so, but yeah, for just the platform parts, for the parts I talked about today, the platform fee is what covers that.
Yeah, and just to expand a little bit on what Joe said, that's configured, as he mentioned, based on how you're using it, for your organization. So right now, the best way to do that would be to talk to us, go through a scoping exercise, and we could give you an estimate, either a ballpark range or give you an actual quote if we go through the full scoping exercise. So I would encourage you to get in touch with us, either Nick at earthmover.io, Joe at earthmover.io, or sales at earthmover.io, and we can follow up with you.
Yeah, I didn't get to this slide, but my email is now on the screen. So cool. Okay. Well, are there any other questions here?
Maybe ask one more.
Yeah, please.
So mostly the most challenging thing that we are currently facing is trying to implement ETL pipelines on AWS.
Yeah.
Is there a way that Earthmover can make it very easy for us, that we don't have to worry about a lot of configurations and set up specific architecture for that?
Yeah, it's a good question. We definitely have some references that can help you there. That our product today does not have a specific ETL tool. It does help manage the data end of that in a way that makes it much easier to do ETL in a sane way. So Icechunk transactions are an important part of that. The ability for you to safely update mutate data sets without potentially destroying a data set that you are working on is an important part of the offering. So yeah, but one thing we've done is and happy to follow up with this as well is we've built some templates for common data sets for how to do ETL with a number of different kind of ETL tools, serverless or otherwise. And so happy to point you to one that looks close to what you're working on.
Okay, that would be great. Thanks.
Cool. Okay, and we have a hand raised.
Yes, it's for me. Hi, I joined very, very late, so I'm sorry. Maybe I probably missed an important part of the call, but I don't work with geoscience data anymore, unfortunately. I do much less exciting thing, but I've always thought that for my use cases, formats such as Zarr would be, very useful and actually adaptable to what I'm doing. And I'm wondering, it's more of a Zarr question. So I'm wondering, how does this play with Scala in general, with the Scala ecosystem? So because every time that I look for something related to Zarr, I've always seen Python packages, and I guess the data format is actually written in Python itself. So I'm wondering how this plays with Spark, specifically Spark or other Scala ecosystem.
Yeah, absolutely. Okay, so it's a good question. I wish I had a great answer for you off the top of my head, because I don't totally know what that what the state of the art is for the Scala ecosystem in Zarr. I can tell you that Zarr is not Python only anymore. It started there. The very first versions of Zarr and Zarr Python were how the data format came to be. But there are now implementations of Zarr in a bunch of different languages, and you might have missed this at the beginning, but Rust, C, Fortran, Julia, R, a bunch, right? And so it's conceivable that there's an implementation out there that is Scala compatible, but I don't know for sure.
Thanks.
Can you tell me briefly what you're working on now? It sounds like you said not as interesting, but I'm actually interested.
No, it's basically it's metrics about users, but it's basically a cube. So it's being metrics about users that we have on our platform. We want them on different dimensions. So dimensions may be time, which can be one dimension, and also over the different platform streamings that they're streaming from. So it's basically a huge cube, multidimensional.
Yeah.
So it's perfect for something like, I used to work with the radar data, so they were NetCDF mostly, radar data, and distrometers as well in my previous job. And so I thought, nowadays we use Parquet, but you know, it's a very good use case, this one, for something like Zarr or NetCDF.
Yeah, cool. Okay, well, I'll look into the Scala thing and we'll follow up for sure.
Thanks.
Yeah. All right. Well, unless there's another question, I want to say thank you to everyone and really appreciate everybody's time and for folks coming by.